Hi everyone, welcome to the Sculpting for Design class. My name is Reed Johnson. You can find me on social media at RDmaker. And this is our first class. So taking a look at what we're going to cover in the class overall, we're going to model sculpted designs, things like furniture, helicopters, mice, more flying things, flashlights, furniture of all sorts, go-karts, consumer products, and even a car. We will also take a look at lattice structures, finite element analysis, and part optimization. For this class, we will use Autodesk Fusion 360. The cloud-based infrastructure of Fusion 360 lets me work collaboratively with others. I can even go so far as to share my work out with the world here on the Fusion 360 gallery. This project, for instance, I've created here is a sculpted form. I created this form, then I created this rendering and shared it out. I heard back from a colleague in Germany who saw what I was working on and wanted to test 3D printing with wood fibers, and he sent me back this image. Fusion 360 harnesses multiple modeling techniques so that we can use various techniques to create a model. For example, Fusion 360 has solid parametric modeling, surface patch modeling. It allows us to use reality scan captured data like mesh, and also use T-spline sculpting tools. For example, in this chair model, I'm currently using a sculpted body to create the seat. This is a very ergonomic form that I can push and pull to create the perfect seat shape. The cool part is I'm using this sculpted body, but I'm also using parametric modeling features to create the perfect seat. For instance, here I'm adding a fillet on the edge. Fusion 360 also lets us go directly from our digital model to physical prototypes using digital fabrication. With Fusion 360, we can also harness existing online data such as the McMaster Car library to enhance our models. In addition to 3D printing, we can also use Fusion 360 to harness other manufacturing techniques such as laser cutting. Here I'm taking the chair model and dividing it up into interlocking slices. Fusion 360 also includes tools for CNC machining. This is a connector component portion of the chair. You can see here I'm generating tool paths that will drive a CNC mill to cut the part from solid stock material. After generating these tool paths, I can generate G-code that will be processed by a CNC machine to create the physical part. For this class, you will need access to Autodesk Fusion 360. For students and educators, you can create an account by going to autodesk.com/workshop. You will also need a headset to hear the audio for each of these videos. I also recommend using a computer mouse to help you navigate inside Fusion 360. I also recommend a second screen for watching these videos while you follow along with Fusion 360 on your actual computer. This can be a smartphone, tablet, or a second screen of any type. I look forward to having you in class as we hone our skills in 3D modeling with sculpting for product design.